All right, our next topic is on multiplying radicals this time. So like the other operations, the shelf number has to match. That guy out on the shelf, if they are not the same, then they cannot be combined for any of the operations that we're doing. They have to be the same. Okay? When it comes to multiplying though, these inside numbers do not have to be the same. They do not have to match. Because what's going to happen is we're actually going to combine them into one radical, same number on the shelf, and you just take the inside numbers and multiply those guys together. So 12 times 6 would become 72. But of course, we know now that we don't want to leave it like that. We need to try and see if it breaks down. So cubed root of 72. I know it was 12 and 6, so I could start there. 2 and 3, this is 3 and 4. I'm just going through and factoring real quick. So this is actually the cubed root of 2, 2, 2, 3 2s, and 2 3s. Okay, group size is 3. I've got 3 2s. 1 makes it out. 3 and a 3 are left over inside. We multiply to make 9. So the answer to this original problem, oh man, did you see me erase that? Hit the button. 2 made it out. Left over inside was 3 times 3, which is 9. So that is the final answer to this original problem. So multiplying, that's it. You make sure the shelf number matches. You multiply any numbers that are outside. The people that are outside jail can be multiplied together. The people that are inside jail can be multiplied together. So you're joining them into one radical, whatever the index is or whatever, one radical. And then in the end, don't forget to simplify. Number one step, people will give me this answer and it's not actually finished. All right, let's try this one. So 2 is on the outside, he's going to stay on the outside. Checking my shelf numbers, there's nothing there, so you assume it to be a 2, which means they're the same. Yeehaw. Now we're going to combine it into one radical. 5 times 15 on the inside. Okay, if I multiply that out, 2 is on the outside, so he's not being multiplied by anybody. And inside, 5 times 15 is 75. And then the last step is to simplify. I'm going to break that down. So it's actually 2, and then inside the square root, 3 times 5 times 5. Looking for pairs. So if 5 makes it out, 3 is left over. Don't forget the 2. So the final answer would be 10 square root of 3. So how is this different from adding and subtracting? Adding and subtracting, we were just counting. The numbers on the shelf had to match, just like this one, but then the stuff inside had to match so that we could count how many of those things we had all together. Multiplying, we're taking this jail and we're combining them into one jail, which means all those inmates, all those prisoners are going to be combined together by multiplying. Now, quick side note, you'll notice if I had stopped right here and just factored these guys down, I would have got the same numbers on the inside as I did after I factored it out after multiplying it. So if you see what I'm saying right there, you don't have to go from 5 times 15 is 75 and then break it back down. You can just factor after you combine them underneath one radical. But that's up to you. Could have done it up here with these guys too. If you don't see it, that's okay. Don't worry about it. Follow my blue steps. All right, let's try this one. This one says 2 square root of 3 squared. Well, squared right here means that you're multiplying 2 of them together. All right, we've got a 2 and a 2 that are both on the outside, so I can multiply those guys together. And then we've got a square root of 3 and a square root of 3 being multiplied together. Okay, multiplying radicals, shelf number has to match. If it does, you're going to combine them into one jail. The numbers on the outside, you would just multiply like normal. And then you're going to reduce. 2 times 2 is 4, so that 4 is going to go out in front. And then I've got 4 square root of 9. Or if you happen to look back up here, look, my group size is 2, and I have 2 3s in there, which means I can actually pull one of the 3s out. So 1 makes it out, 1 dies, and there's nobody left in the prison. It's gone. Bring down your 4 times, and your final answer there is 12. So one more time. 2 square root of 3 squared. I wrote 2 of them and multiplied them. Numbers that are outside, right? The 2 times the 2 can be multiplied together. They made this 4. The numbers that are both in radicals can be multiplied and combined into one single radical. And then this step right here, it was already factored. When I multiplied it together under the same jail, joined them together, they were already homies. I didn't have to go back and multiply them together and then factor them back out because those guys were already homies. So, little shortcut there. Okay, what color to choose? Okay, let's check. Do our shelf numbers match? Yes, so we can combine them. Do I have any numbers outside? There's no number here, so we assume it to be a 1, and there's a 3. So I'm going to take those guys and write them out here. And then we've got 2 radicals. We've got the cubed root of 4x squared times the cubed root of 8x. So we have got 2 radicals, and we're multiplying together, and they've got the same number. We're going to combine them into one radical, so 4x squared times 8x, and then 1 times 3, this out here is just 3. We'll carry that getaway driver, right? He's out there waiting. Now, if you look at that and you can see already what can be pulled out and that kind of stuff, great, go for it. I'm going to combine the stuff together. 4 and 8, that's 32. And then I've got x squared and another x. That means I've got x to the third, so 3 x's inside. Okay, we're cube rooting. Breaking 32 down. Write it over here. Actually, I shouldn't have to write this one down anymore. You guys should have seen it enough, or at least I could go right to writing it out. 5 2's. And then it says to do 3 x's, because it's x to the third. All right, looking for our homies. Oop, don't forget this 3 out here. Getaway driver. I got 3 homies here. How many make it out? 1. The rest are gone. Only 2 more x's. They can't, or 2, sorry. Then I do have 3 x's, so an x makes it out. The rest are gone. And inside my jail is these 2 2's, or 4. And then, of course, the getaway driver, we multiply everybody outside together. So 3 times 2 is 6x. And then our jail with that poor little 4, or the 2 2's sitting on the inside. So that one's the answer there. All right, this one right here. This next one, we've got negative. It's not subtract because there's this in front. It's negative 5th root of 3 multiplied by 4 times the 5th root of 162. Now, as far as this 5 is concerned, we just need to know that that's the same. And then when we get down to reducing, we need to have groups of 5. That's the only thing that's important about that. Otherwise, you can ignore it for the rest. Okay, let's talk about the outside pieces. So right here, I've got a 4 on the outside, and then over here, there's no number written, so I'm going to assume it's going to be a 1. Dun, dun, dun. Superhero comes in and says, hey, something's missing, let me hold the place for you, right? I'm the superhero, I'm invisible until you need me. So my numbers outside are -1 and 4. Then I've got these 2 radicals. I've got the 5th root of 3 times the 5th root of 162. I'm going to combine those together into one radical. fifth root, 3 times 162. And then you can go through and you can factor that out. You'll end up with 486 maybe? I don't know. I'm going to break it down from here. 3 is already prime, so I'm going to leave 3. I'm going to break down 162 into my numbers. Oopsie, do you see it? I hate when that happens. Like just says, hey, I'm going to pull a trick on her and I'm going to move it. Watch me go. Boop. 3 and 9, 3 and 3. So it looks like this is the fifth root of 3, that's this guy, times 2, 3, 3, 3, 3. So 2, 3, 3, 3, 3. Okay, no variables, we're good there. These guys multiply together to make -4. That's our getaway driver. So looking inside there, do I have 5 of anything? Now they're not written in order. It doesn't have to be. What matters is that I do have a group of 5 3s. Only one's going to make it out. The rest of them are gone. And then who's left in jail? This poor little 2 guy all by himself. And of course the getaway driver. Everybody on the outside multiplies together. And you get -12 cubed root of 2. It's an awfully big radical, isn't it? Okay, so quick recap. When you're multiplying radicals together, you multiply any outside numbers together and any inside numbers together, and you keep them inside the jail. But then you go back to what we learned at the very first, simplifying radicals, breaking people out of jail, what's my group size, that kind of stuff, until you get your final answer. Even if there's variables, doesn't matter, the process is still the same. Outside numbers get multiplied together, inside numbers and variables get multiplied together underneath one radical, and then it's all about simplifying.